let's continue with 14c on the new tangent function, and just going back to where it's coming from and its features. And 14d is going to be we'll review the trigonometric ratio and apply that to the units circle. So again, on the picture that you can see on your screen, you do have a circle of radius 1, which we call the unit circle. P is a variable point on the unit circle. It has an angle theta with the positive direction of the x-axis, and what we're going to do with that is we're going to extend it, and from the right hand side of the circle we're going to extend a tangent line. So remember, a tangent line to a circle is just slightly touching or intersecting only at one point. So that vertical line, which is also parallel to the y-axis, will intersect at a point C. Now that point being on a vertical line, we have an x-coordinate of 1. What else do we know? P is a coordinate of cos and sine theta, and so on. We're gonna focus on two triangles. So we look at the triangle, the smaller one, OPD inside the circle, and then OCA. Now those two triangles are of a different size, but all the angles are the same. They both have an angle theta, they both have a right angle here, and that third angle has to be the same. Therefore, the triangles are similar. If you review the definition or the theorem about similar triangles, it means the ratio of the corresponding lengths are the same. So for example, if I do OC divided by OP, it should be exactly the same as OA divided by OD, and vertically will be OC divided by that vertical line, A to whichever, but that corresponds exactly to sine of theta. So if we apply the ratio from inside this triangle, so sine theta over cos theta, it's going to be AC over OA, but because OA is equal to 1, that ratio AC is also equal to sine over cos. And that's the definition of tangent. So graphically, if you draw a tangent line and you extend that line, that vertical measurement is your tangent. A few features. The first one is tangent is sine over cos. Cos of theta, the denominator, if it equals 0, because you can't do a division by 0, it will be undefined. At that point here, 0, 1, cos of theta is 0, therefore tangent is undefined. And if I go all around to 0, negative 1, again cos of theta is equal 0, tangent is undefined. So this expression here, bracket 2k plus 1 times pi over 2, it means it's a multiple of pi on 2, but the 2k plus 1 says that it is an odd number. So it's going to be also negative, but 1, 3, 5, and so on. So 1, 3, 5, so if it's 1, we up here. Down here is 3 times pi on 2, and we keep going around, and that's 5 times pi on 2. So those values, 2k plus 1 times pi on 2, are excluded from the domain. So the domain is R backslash curly brackets to define the set, and bracket 2k plus 1 times pi on 2. And that's it for tangent. 10D, trigonometric ratio. So let's put all of that together. So we have sine, cos, and tangent from your SOHCAHTOA in a right angle triangle is equal to all of that. If we apply that to the unit circle, so we have a circle of radius 1, it implies that OB, or the hypotenuse of the right angle triangle, is equal to 1. We can simplify our trigonometric ratios. So sine, cos are x and y, which is what we had in 14b. They represents the coordinate of the point we named P before on the unit circle. And tangent theta from the previous slide is a ratio, so it's the opposite of the adjacent. It's also a y over x or sine over cos. And in the first quadrant, so when the angle is between 0 and pi on 2, so 0 to pi on 2, we can define sine, cos, and tangent by the trigonometric ratio with the circular functions that we've covered. And that's really it. So told you it will be short, and I'll see you next time.